Warm welcome you all to channel Meet MIT, that is Math is Tricky.
In this video, I'm going to share some tips and tricks about domain and range of a function. I'll be dealing with the concept and definition of domain and range of a function, and then I'll be solving some problems based on it. Let's see what is domain of a function. So domain of a function f from a to b is the set of values of x belongs to a for which the function is defined, and it is denoted by df. Thus domain of f, that is df, equals set of all x such that x belongs to a for which fx is defined. This is the domain. Actually, the domain of a function means a set of inputs for which we'll get the output. That means the values of x which will give definite value of y. Okay, so that is domain. Now let's see what is range. Range of a function f from a to b is the set of values of y that belongs to b corresponding to each x belongs to a, which runs over the domain of the function, and it is denoted by r of f. Thus r of f, that means range of function f, equals set of all fx such that x belongs to domain of f. It means here range of a function means it is all the values of y for all the values of x. Okay, so it is set of all fx such that x belongs to domain of the function. It means here range of a function means it is all the values of y for all the values of x which belongs to domain. Okay, it means it is all the outputs, whatever outputs we'll get for the values of x in the domain. Okay, this is the range. Hope you understood. And now to make it more clear, we'll be solving some problems. So let's see first number, question number 1. Okay, my dear students, today in this video I'm dealing with domain and range of a function, and I've already explained what is domain and what is range. Now we'll solve the problem and try to understand it. Okay, so first question is here. We are given fx equals x square minus 6x plus 6, and now we are going to find the domain and range for this function. Okay, so as we know that domain is all the values of x for which the function will be defined, or for which will get definite value of fx or fixed value of fx. So okay, so we can easily see that for all x belongs to real number, for all the values of x, fx is defined. Okay, that means fx gives a definite value or finite number for all x belongs to r. So domain of this function equals the real value, set of real values, that is r, that equals, also we can write here, minus infinity to plus infinity. This is the domain of the function. Now let's move for range of the function. So we are given here fx, which we know that which is same as y equals x square minus 6x plus 6. Okay, so let's simplify the right hand side, so that by putting there plus minus 6 plus 6 minus 6, we'll get here x minus 3 whole square and minus 6 plus by putting here. So okay, let's move for range of the function. So fx equals y, which equals x square minus 6x plus 6. Now we can write here x square minus 2 into 3 into x, that means 2ab plus 3 square and minus 3 square, that means plus 9 and minus 9 gives x minus 3 whole square minus 3. Now let's bring minus 3 to right hand side, so that we'll get here y plus 3 equals x minus 3 whole square, and as right hand side is square of x minus 3, so we know that a square of a number is always greater or equals to 0, so we can write here x minus 3 whole square equals greater or equals to 0. That means y plus 3 is greater or equals to 0, so we can write here y is always greater or equal to minus 3. It means here minimum value for y is minus 3 and the maximum will be infinity. So our range for this function is the closed interval minus 3 to infinity. Okay, this is the domain and range for this function. Now we'll move to, now we can solve this problem, the same problem. I'm just going to tell you or share, I'm going to share with you another method or alternative method you can say, or you can say shortcut method also, trick also. So we know that easily by looking we can say that fx is second degree polynomial, so it is always defined for all the values of x. So infinity minus infinity to infinity, or the set of real number will be domain. Now for range we can use direct formula. So it is, as it is quadratic and we know that it gives a parabola, so parabola means either maximum or minimum value we can find. So since the value of x square is positive, so we know that it's positive means it will be upward. It gives a parabola which turns upward, so we know the minimum value of y and the maximum will be upward, means it is infinity. So we can write here, this is what I'm writing here, comparing with y equals ax square plus bx plus c quadratic quadratic polynomial. So a equals 1, b equals minus 6 and c equals 6. Since a is positive, maximum value of fx will be infinity because it gives a parabola turning upwards. So maximum value is, now we need to find the minimum value. To find minimum value we have direct formula. Okay, so minimum value, to get minimum value we can use direct formula, 4ac minus b square by 4a. So 4 into a means 1, 4, c is 6, so 24 minus b square is 36. So 24 minus 36 minus 12 by 4 gives minus 3. That means our range will be, minimum value is minus 3 and maximum value is infinite. So by using this formula, or we can say here trick, we can have the answer in very short time. Now we'll move to next question. Number 2 is here. Again this is also a quadratic polynomial. So same as before, we can write the domain for all value of x. Function fx is defined, which gives, that means it gives a finite number or a fixed number. So domain will be simply real number, set of real number, or minus infinity to plus infinity. We can write in open interval form. So for range as before also, let's try to express the right hand side as whole square. So by putting here plus 1 and minus 1, we'll get here y equals x plus 1 whole square plus 2, and then we'll get here by simplification y minus 2 comes to left hand side, so it will be negative, and which equals x plus 1 whole square, which is always greater or equals to 0. So we can write here y minus 2 greater or equals to 0. Therefore y is greater or equals to 2. It means here minimum value is 2 and more than 2, so up to infinity. So our range is closed interval 2 to infinity. Okay, this is our answer. Now again, as before, domain we know, since it is a quadratic equation, so it is defined for all, since it is a quadratic polynomial you can say, so it is defined for all values of x. So we can direct say domain equals real number, set of real number. And now for range as before, we can use the formula 4ac minus b square by 4a. So we know here a is 1, b is 2, c is 3. By putting the value of a, b, c, will get here minimum value of fx is 2. 4ac means 4 A is 1 and C is, so 4 into 3, 12, 12 minus 4 will be 8, 8 by 4 is 2. And as the coefficient of x square is positive, it gives a parabola which turns upward, so minimum value will get here and maximum value will be infinity. So again we'll get here closed interval 2 to infinity as the range. Let's move to question number 3. So once again we have another question and it is in quadratic form. So x square minus 1. So as before we can write the domain for this. It is easy as it is defined for all values of x. So domain will be set of real number. Now for range, as before, we'll try to express the right hand side is in whole square. So already there is the variable is in terms of whole square, so we can write y plus 1 equals x square, and x square is always greater or equals to 0. So we can write here y plus 1 greater or equals to 0. So y is greater or equals to minus 1. It means here the value of y will be always greater or equal to minus 1. It means range will be closed interval minus 1 to infinity. Now by trick method also we have the same answer. So for domain, no confusion, we can direct write domain will be set of real number because it is defined for all the real values of x. Now for range, we know the formula. Again x square, the coefficient of x square is here 1 and which is positive, so it gives a parabola turning upward, so minimum value will be there and maximum value is obviously it goes up and up, so it will infinity, maximum value is infinity. To find minimum value we'll use the formula 4ac minus b square by 4a, and which gives on simplification as minus 1, which is same as before, minus 1 to infinity. Closed interval minus 1 to infinity is our range for question number 3. Okay, my dear students, hope you are understanding this. Today in this video I'm sharing ideas and tips and tricks about domain and range of a function. So hope you are getting this. And now we are here for question number 4. Already we have solved some problems. Now let's move to question number 4, and here it is. It is again quadratic polynomial. So it is defined for all the real values of x. If you put here whatever value of x, so we'll get a finite number. So the domain will be a set of real number, that is in interval. We can write here in the form of interval minus infinity to plus infinity. Now for range, as before, we'll try to express the terms containing variable in right hand side as perfect square. So what we can do here, let's take first minus common, so we will get here x square minus 4x plus 3 in right hand side, and now we'll try to express this in a perfect square form, so that by putting plus minus 4 we'll get here minus 4 plus 3 is minus 1, so minus x minus 2 whole square minus 1, and now it gives here y equals minus a bracket open x minus 2 whole square plus 1 minus minus plus, so bringing minus. So now let's bring x minus 2 whole square to left hand side, so it will be positive, yeah. So and y minus, let's bring y to right hand side, so that we'll get here 1 minus y, we'll get here y minus 1. Okay, so we'll get this as y minus 1, or okay, simplify, we can simplify this in any way. So bringing this 1 to left hand side, it will be y minus 1 equals minus x minus 2 whole square. So as x minus 2 is always positive, right hand side is always negative, so y minus 1 is less or equals to 0. Okay, so it means here y is less or equals to 1. That means we get here the minimum value of y. So sorry, in this case we get here maximum value. Y is always less than 1, means maximum value of y will be 1, others all values will be less than 1. So from maximum value is 1 and all the values are less, means it will go to minus infinity. So minus infinity to plus 1, close interval at 1. So this is our range. So also, so as I was discussing, so we can bring this as x minus 2 whole square equals 1 minus y. 1 minus y is always greater or equals to 0, because x minus 2 is x minus 2 whole square is always greater or equals to 0. So 1 minus y greater or equals to 0 means 1 is, we can write here 1 minus y is greater or equals to 0 means 1 is always greater or equals to y. That means y is always less or equals to 1. From that also we can have the answer. Now let's see what is the trick and how can we write the answer in just second. Okay, so this can be used in entrance exam. So for domain, no worry, it is quadratic polynomial. So domain will be set of real number minus infinity to plus infinity. For range, as before, see here, it is quadratic polynomial, but coefficient of x square is negative, so it gives here a parabola which turns downward, isn't it? Which turns downward. So downward means maximum value, we can find the maximum value. So minimum value will be minus infinity. To find maximum value, we can use the previous formula, 4ac minus b square by 4a. So 4a is minus 1 minus 4 and into minus 3, 12 minus b square is 4 square 16, 12 minus 16 is minus 4 by 4a, minus 4 by minus 4a is 1. Again we have the maximum value is 1. So 4ac minus b square by 4a in this case will give the maximum value. Okay, because coefficient of x square is negative, so it means here the parabola will be turning downward. Now let's move to question number 5. So the function is here fx equals 3x plus 1. Okay, so question number 5 is here fx equals 3x plus 1. So easily we can see for all the values of x we'll get definite value of fx, that is fx is defined. So domain of f will be set of real number. And now we'll move for range. To find the range, we'll try to find the value of, for all the domain, what will be the value of fx. So if you put all the real numbers, 3x plus 1, the function will give all the real values. That means always define for all the real values of x which are the domain. We get again fx is defined, that means we get definite number, we get fixed values of y, so we get here finite values of y. So the range is also here the set of real number. Okay, so for all x we can have the definite value of fx. So real set of real number is domain, and for all real number, we according to this function will get real value. So range is also set of real number. Now question number 6. Okay, so this is cubic polynomial fx equals x cube. So for domain, for all the real values of all the values of x, fx is defined. That means fx gives finite number, finite value, definite value for all x belongs to R. So domain of f is set of real number. And for range, for all the real values of x for that belongs to the domain, we have definite value of fx, that is fx is defined, and we get definite values of fx which belongs to the real set of real number. It means in this case also domain and range of the function, its domain and range of the functions are same, and that is set of real number. Okay, it's so simple. Now okay, so question number 7. My dear students, today in this video I'm sharing ideas and solving the problems based on domain and range of a function. So we have already solved some problems. My dear students, if you understand this, if you like this video, please like and subscribe my channel. Please watch my previous videos and give your feedback. Please you comment and write how you are feeling, and please subscribe my channel and share among your friends. Now let's move to question number 7. Question number 7 is y equals square root of x minus 2. Okay, so for this we're going to find domain and range for this function, isn't it? So how will we find it for domain? So what are the possible values of x for which this function will be defined? So we know that we can find the square root of any number if it is 0 or more than 0. Okay, so while we define if x minus 2, the number is inside the root will be 0 greater or equals to 0. So it means here x minus 2 is greater or equals to 0 or x is greater or equals to 2. So domain is the closed interval at 2 and open at infinity. So that means half closed, half open. So 2 to infinity is our domain. That means 2 for 2 or more than 2 it is defined. Now it means here we can, the minimum value for x is 2. If you put 2 here, we'll get here y equals 0. That means the minimum value of y is 0. Okay, more than 2. So as we put a greater value of x, will get greater numbers. That means it will go on increasing. So our minimum value will be that means minimum value of y, that is range, will be 0 and furthermore. So and our range will be closed at 0, so half closed and half open interval. So our range will be 0 to infinity, closed at 0. Okay, now let's move to question number 8. Here similar type of question is there, y equals square root of x plus 5. So as we know that to get the function will be defined, the value of y will be defined only when x plus 5 is greater or equals to 0. It means here x is greater or equals to minus 5. So domain will be minus 5 to infinity, closed at minus 5, half closed and open interval. So now to find the range, as we know that our minimum value of x is here minus 5. So if you put here minus 5 in the given function, it will get here minus 5 plus 5 is 0. So the minimum value of y is 0. And as we go on increasing the function, so the value of, as we go increasing the value of x, greater value will get and the square root of that will be greater. So our minimum value for y is 0 and more than that. So one more thing you have to remember, that while taking a square root, the function is defined only for positive square root, so we can take negative value. So minimum value will be 0 and maximum value will be up to infinity, more than 0. So our range will be 0 to infinity in this case. Now another question is here, similar question, root x, y equals root x. So as before, we can say that this function is defined only when x is greater or equals to 0. So the domain will be closed interval at 0 and open at infinity, half closed, half open. So 0 to infinity is our answer, and 0 we can take, so it will be closed at 0. For range, we know that this is always for this type of function, square root of a function means in that case it is only defined for positive number, and we can also take 0. So range will be 0 to infinity, because here the minimum value of x is 0. So for square root of 0 is 0, we take only positive square root. So and so on, more than 0 will get. So 0 to infinity is our range in this case. Now another question is there, question number 10. Okay, my dear students, hope you are understanding this, hope you are enjoying this. So if you have any confusion, please write it in comment, and so that I can help you and I can explain it for you. Now let's move for the solution of this question number 10. Y equals 1 by 1 plus x. So now for domain, we know that we have to find the value of x for which the function is defined, isn't it? So now what are the possible values of x for which the function is defined? So this is a fraction. So in fraction, we know that if fraction, in case of fraction, denominator becomes 0, the function will not be defined. It means here this function, that means y is always defined, but we can take here x equals minus 1, because if we take here x equals minus 1, the function becomes, it gives undefined number. That means we can get finite or the definite value of y. So we can put all the value of x which belongs to real number. For that the function will be defined, but it is not defined for minus 1. So we can write here in this way, y is defined for all x belongs to R except x plus 1 equals 0, that is x is except at x equals minus 1. So domain will be all the real values, real minus minus 1. So minus 1 does not belong to this set. Okay, it means here domain is R minus minus 1. So set of all the real values except minus 1. That means in that set minus 1 will not be there. Okay, now for range, what should we do? We'll try to find the value of x. Let's express the given function in terms of x. So doing reciprocal on both sides, we can write here 1 plus x equals 1 by y, and now x equals 1 by y minus 1, it means 1 minus y by y. It means here we can't put y equals 0. Okay, so because if you put y equals 0, it will give here undefined number, but we have already chosen, that means x is defined. We are taking all the values which are defined. So in this case, x, to get finite value of x cannot be 0. So we can take under all values. So the range will be all the numbers, all the values of set of real number except 0. So R minus 0 will be our range in this case. Now we'll move to another question number 11. So we have already discussed so many questions here, 10 questions now, and I think you can do this type of questions. Already we have discussed in previous video also, and then so you can do by yourself. So this again, in this case also, the function is defined for all the values of x which belongs to real set of real number except at 1. Okay, that means x minus 1 equals 0. That means we can't take x equals 1, because for that the function is not defined. So the set of real number minus 1, that means R minus set of 1, is the domain. Now we know that as before, to find range we'll express the given function in terms of x. So we'll try to find the value of x in terms of y. Okay, so we can write here by doing reciprocal, we can write by simplification also we can do here. So 1 minus x equals 1 by y. It means here x equals 1 minus 1 by y. It's y minus 1 by y again, which is not defined for y equals 0. That means we can take y equals 0. So the value of y is the value of y as 0 is not included, but other all values we can get. Okay, so and for other all values x will be always a real number except 1. Okay, so the range will be R minus 0. That means we can't get 0 as the value of y for this type of function. R minus 0 will be R minus set of 0. That means except R 0, others all values of real number will be the range. Okay, so now another question is there, question number 12, and here it is x square minus 16 by x minus 4. So now always in terms of if the function is in terms of fraction, always think about the denominator. It shouldn't be 0. That means, so if we put here x equals 0, the function is not defined. That means as y is defined for all the values of x belongs to R, but it is not defined for x equals 0. That means it is defined for all x belongs to R except at x minus 4 equals 0. That is x equals 0 at except x equals 4. So domain will be R minus 4. So because for 4 it is not defined, for others all it is defined, R minus 4 is the domain. As we know that in domain we have not included 4. Okay, so for other all values of x it is defined, so we can simplify this function as x minus 4 times x plus 4 for x square minus 16 means 4 square. We can use a square minus b square formula so that we can cancel x minus 4 and x minus 4 from numerator and denominator, so that we'll get x plus 4 as the function. And now it is, we can see here, it is defined for all the real values of x. But we know that as 4 is not included, if you put x equals 4, we'll get here y equals 4 plus 4 8. So it means here, as we don't have 4, we will not get 8. But other all values, for others all values, this function is defined. Y equals x plus 4 is defined, because x equals y minus 4, we can get finite values which belongs to the domain. So for all the domains, value will be defined, but will not get 8 because 4 is not in our set of domain. So in this case, our range will be simply, range is simply here r minus 8, because r can't be obtained as value of y because we don't have 4 in our domain. Okay, now let's move to question number 13. Similar to the previous one, x square minus 1 by x plus x minus 1. So as before, we can see that it is defined for all values of x except at x equals 1, that means x minus 1 equals 0. So domain will be r minus 1, set of 1, singleton set. So except 1, it is always defined. So our domain is r minus 1. And now if x is not 1, so we can simplify and get y equals x plus 1, and which gives x equals y minus 1, and which always belongs to, y minus 1 belongs to set of real number. But we know that we don't have x equals 1 in our domain. So if you put here, we have to eliminate the value of y which is obtained at x equals 1. That is, if you put x equals 1, the value of y is 2. So it will not be in the range. Okay, so 2 will not be in the range because 1 is not in our domain. So it means here our range is r minus set of 2. Okay, so r set of all the real values except 2 is the range in this case. So my dear students, today in this video I'm explaining and solving some problems based on domain and range of a function. So hope you are enjoying, hope you are understanding this. My dear students, mathematics is not difficult, it is not tough, it is not boring. We can make it mathematics as interesting subject. We can make it easy, we can make it tricky, and we can enjoy mathematics, we can understand mathematics. It's all about our practice, it's all about our hard work, it's all about our technique to learn the mathematics and practice mathematics, or understand mathematics, or do mathematics. Okay, so now let's move to question number 14. Here we have another function y equals square root of x square minus 2x minus 8. Okay, to at first we'll find the domain for this function. Okay, so as we know that square root of a function is defined only when the number inside the root is greater or equals to 0. So it is we can write here y is defined, the function is defined if x square minus 2x minus 8, the number inside the root is greater or equals to 0. So we'll try to express this in whole square form. So by putting plus 1 minus 1, it goes in the formula of x minus 1 whole square, and minus 9 minus 1 minus 8 will minus 9 equals greater or equals to 0, which means x minus 1 is greater or equals to 9, and whole square is can be written as modulus square is greater or equals to 9. So modulus x minus 1 is greater or equals to 3. It means here x minus 1 is greater or equals to 3, because we know that the modulus x is defined as modulus x equals x if it is greater or equals to 0, modulus x equals minus x if it is less than 0. So this is what we are going to do. So for my x minus 1 greater or equals to 0, modulus x minus 1 will be same as x minus 1. So from that we'll get here x is greater or equals to 3 plus 1, that is x is greater or equals to 4. So the minimum value for x is here 4. Now for second part, when x minus 1 is less than 0, modulus of x minus 1 will be minus x minus 1, which gives x minus 1 is less or equals to minus 1, that is x is less or equal to minus 3 plus 1. It is here x is less or equals to minus 2. So greater than 4, that means 4 to infinity, and less than minus 2 is minus 2 to minus infinity, and union of these two interval is our domain. Okay, so this is our domain in union of these two intervals. Okay, now we'll move to the range of this function. How to find the range of this function? So to find the range, we can, by squaring, we can write here y square equals x square minus 2 minus 8, and now expressing right hand side as whole square, we'll get here x minus 1 whole square minus 9 by putting plus minus 1 on right hand side. And now let's bring minus 9 to right hand side, sorry, left hand side. So it will be y square plus 9 equals x minus 1 whole square, and x minus 1 whole square is always positive. That means y square plus 9 is greater or equals to 0, which is always true for any values of y, which is true for any values of y. But we know that this relation will become a function. This type of function, square root of any function, is defined only when for the positive square root. So we can take all the values of y, but it should be 0 or positive, because square root is defined, such type of function is defined only for positive. That means all the positive square roots, we can take a 0 or positive square root. So the value of y should be 0 or more than 0. So range will be the closed interval at 0 to infinity, 0 or more than 0. Okay, so y is to define the function, this type of function, y should be 0 or more than 0. Now to solve this type of problem, we have a trick also. So now I'm going to share a trick so that you can solve this type of problems within seconds, and here that means you can solve this type of problem in very less time. So what is the trick or the alternative method to solve the same problem? This method can be used in entrance exam. Okay, to find the domain first. So what do you do? Factorize the number inside the root. Okay, so by just factorizing x square minus 4x plus 2x minus 8 equals 0. So let's factorize and try to find the value of x, which will give which will make the number inside the root at 0. So just factorize and find the value of x, which will give the result as 0. So by factorizing, we'll get here x equals 4 and x equals minus 2. Now since the coefficient of x square, so you have to remember this concept. So if x square, the coefficient of x square is positive, our domain will be the outer intervals, not the middle one. So we can obtain, see here, minus 2 and 4 are the values of x. So we can have 3 intervals, minus infinity to minus 2 and 4 to infinity. It means here, if a coefficient of x square is positive, yeah, so positive means the union of two outer intervals will be the domain. Direct we can write. And in such type of function, always if a square root of a function is there, so always the range is 0 to infinity. You can remember this. Don't have to. So we have, and to explain, to know, to understand more, to what is the explanation, so you can see the previous videos. And is 15 number here, question number 15, y equals square root of 21 minus 4x is 4x minus x square. To find the domain, okay, for domain we are discussing here. Let's first find the domain. So y is defined if the number inside the root is greater or equals to 0. So it means here 21 minus 4x minus x square should be greater or equals to 0. Let's simplify that. 21 minus x square plus 4 by taking minus will get this, and now 21 minus x plus 2 whole square, okay, and just put here plus minus 4 to change this in perfect in whole square form. So minus minus plus will be there, so 25 minus x plus 2 whole square is greater or equals to 0 as before. Just we can solve this. 25 5 square is greater or equals to x plus 2 whole square. It means here x plus 2 whole square is less or equals to 5 square. So taking square root, we will get here x plus 2 is less or equals to 5, or positive modulus value of x plus 2 will be less or equals to 5. So we know that modulus x less or equals to a is minus a to a. So we can write a minus 5 is less or equals to x plus 2 is less or equals to 5. So by solving this, we'll get here minus 7 is less or equals to x is less or equals to 3. That means our interval is here, that means our domain is between minus 7 to 3. For range, here the function is y equals square root of 21 minus 4x minus x square. For range, let's square both sides, so that we will get here y square equals 21 minus 4x minus x square, and by taking minus common from second and third term, we'll get here x square plus 4, and by adding plus minus 4, we'll get here y square equals 21 minus x plus 2 whole square, and minus minus plus 4 will be here. So 21 plus 4 will be 25. Y square equals 25 minus x plus 2 whole square, which gives 25 minus y square equals x plus 2 whole square. It means here x plus 2 whole square is always greater or equals to 0. It means 25 minus y square is greater or equals to 0. It means here 25 is greater or equals to y square. That means y square is less or equals to 25. Taking square root, we'll get here y is less or equal to 5, as the value of y is always positive. The relation will be a function for only positive square root, so we are taking a positive square root, so y will be less or equals to 5. It means here maximum value of y will be 5, but we can't take here minus y because the function will not be defined for negative value of y. Now we have a trick for this type of function, okay, to find the domain and range in very short way. So let's see here what we are getting. So as before, we'll make this right hand side, that means the number inside the root as 0, and try to find the value of x. So by solving, we'll get here 21 minus 7x plus 3x, breaking the middle term, minus x square equals 0. Or if we take 7 common from first 2 and 3 common from last 2, we'll get here x plus 3 times x 3 minus x equals here minus x square minus 7x and plus 3. Okay, so that's fine. So which gives here minus 7 and 3 as our, so domain is same as before, so no worry. So here, since x square, the coefficient of x square is negative, okay, in previous question the value of x square was positive, so we took here outer intervals. Union of that was the domain in case of previous question, because the coefficient of x square was positive in previous case, but here the coefficient of x square is negative. Negative means it will be between the interval, it will be in the middle interval, so not outer, will take the middle interval. That means the interval obtained by two values of the x. So minus 7 to 3 will be our domain. In this case, remember the trick is here, if x square is negative, the middle one will be the domain, but if x square is positive, out of 2 will be our domain. Now, so to find the range, the trick is here. Range will be 0 is always our answer, more than 0 up to infinity, but in this case not up to infinity will be the upper limit will be for this range. It is here just difference of the values of x, -7 to 3. So take the difference of this number. Okay, so modulus value of that, -7 -3 -7 minus 3 is 10, 10 by 2 is 5, so 0 to 5 will be there, not infinity. Move to question number 16. Question number 16 is here. So it's very important question and tricky question also. So for domain, we know that y is defined for all the values of x, but not one except 1, because for 1 it is not defined. So the set of all the values of real numbers except 1 is our domain. That means r minus 1, set of 1 is the domain. Now we know that modulus, the definition of modulus, so it is here x, the modulus of x is x if x is greater or equals to 0, and minus x if x is negative. It means here modulus of x minus 1 will be x minus 1 if x minus 1 is greater or equals to 0, that is x is greater or equals to 1, and minus x minus 1 if x minus 1 is less than 0, that is x is less than 1. Okay, so by putting modulus, the value of modulus x minus 1 as x minus 1, we'll get here y equals 1, and if you put here minus x minus 1, we'll get here minus 1. That means only two values are possible. Only two values of y are possible in this case for the domain. So range will be -1 and +1. It contains, the range contains only two values, -1 and +1. Now let's move to question number 17. 17 is here, modulus x by modulus x by x. Question number 17 is here, y equals modulus x by x, and which is same as previous one. So it is defined for all the values of x which belongs to real number except 0. So the domain will be r minus 0. And for range, we know that as before we can use the concept of modulus. So modulus x is defined as x for x greater or equals to 0, minus x for x less than 0. So we can get the value of y as 1 if modulus x equals x. So x by x will be 1, and if we'll get here -1 if modulus x equals minus x. So according to this, we have only two values, -1 and 1 for y. So that means for all the values of x in domain, we will get only -1 or +1 as value of y. So our range is a set of -1 and +1. This is the required solution for question number 17. My dear students, hope you understood this. I have explained and I have solved some problems of based on domain and range of a function. So hope you enjoy this, and please you go through all the questions and try many more other problems, and you share with me. And you please like and subscribe my channel, share these videos among your friends, and share your feelings. You provide your feedbacks also, and please subscribe my channel and hit the bell icon so that I can help you, and you will be notified as soon as I'll be uploading the video. Thank you so much. God bless you.
Thank you so much for watching my video. I hope you like this video. Please do share this video with your friends, in your circle, in your social media, and please don't forget to subscribe my channel. Thank you so much. God bless you.